the king of fruits, the mango. Loved around the world, the mango is not just a tasty treat. It's packed with benefits and has diverse applications. Mango, Mangifera indica, is a tropical fruit indigenous to South Asia, especially India, Bangladesh, and Sri Lanka. It is extensively cultivated and consumed worldwide, with more than 1,000 varieties cultivated across the globe. Mangoes are not just for eating, though that's the pretty great use. They can be eaten, sliced, clubbed, or straight from the seed. Mangoes are a summer staple. Mango juice is a refreshing drink, often blended with yogurt and other fruits. From mango sticky rice in Thailand to mango ice cream, pudding, and cakes. This fruit shines in sweet dishes. Now, let's talk beyond the kitchen. Mangoes have a few tricks up their sleeve. Mango butter, extracted from the seed, is rich in vitamins and used in lotions, soaps, and creams to moisturize and nourish the skin.
Now, we are going to analyze the quality of mangoes using 4 key parameters: color, sweetness, firmness, and thermal conductivity. Each tells us something important about the fruit's ripeness, shelf life, and consumer appeal. First up, color. A mango's color is one of the first indicators of ripeness and visual quality. To quantify it, we use the Hunter's Lab calorimeter.
This is Hunter Lab calorimeter. This is used to measure and quantify the color in food. It is a highly accurate instrument used to measure the color of powdered, liquid, or solid foods. This sensor is put on the food item, and on the power, the LAB values will display over the screen. L values varies from 0 to 100. 0 indicates black and 100 indicates white. Then A value red to green axis. Positive A value indicates red and negative A value indicates it is green. Then B, yellow to blue axis. Positive B values indicates yellow and negative B value indicates blue.
Next, we measure how sweet the mango is using a Brix meter, which determines the total soluble solids content.
This is a PSS-based refractometer. It is widely used in food technology to measure the total soluble solid present in food product. It can be expressed in degrees Brix, and it is Brix means it is the content of sugar that present in food products. It is a lid, prism, and there is a eyepiece, and inside there is a scale to determine the value of the food product.
Firmness is key for transport, texture, and determining ripeness. We assess it using a penetrometer.
This is a penetrometer. This is used to measure the hardness, firmness, or consistency of a material. Commonly used in food industry. A fruit penetrometer is a tool used to measure the hardness or firmness or ripeness of a fruit. It is especially used in agriculture and food quality control to determine the best time for harvesting and selling fruit. This penetrometer contains plunger of different diameter for different types of fruits.
Finally, we analyze the mango's thermal conductivity, which affects how it stores and transfers heat, important for cooling and processing.
This is a thermal conductivity meter. It is widely used in technology to measure the thermal conductivity of a food material and to measure how efficiently heat passes through a food material. This is a conductivity cell. This is a thermocouple, and these two are connected to a conductivity meter. And in their display, we can see the temperature and thermal conductivity of a food material.
Have you ever wondered how food gets from farms to your plate? Let's take a tasty journey through the three main stages of food processing: primary, secondary, and tertiary. First step, primary processing. This is the step where raw food is prepared straight after harvest. It includes basic tasks like washing, peeling, drying, milling, or slicing. No other flavors, no fancy packaging, just the food in its cleanest, simplest form. Ready for the next stage? Now, let's spice things up with secondary processing, where real transformation begins. This stage turns basic ingredients into actual food products like mango jam, bread from flour, or tomato ketchup. It's where science meets flavor. Yes. Finally, we have tertiary processing, the world of ready-to-eat convenience foods. These are the packaged, processed, and often preserved versions of food. Just open, heat, and eat. It's food made for busy lives, fast, easy, and shelf-stable.
Now, let's dive into the world of mango preservation, exploring how we can extend the shelf life of this delicious fruit while maintaining its flavor, color, and nutritional value. Preservation techniques help reduce post-harvest losses, allow for year-round availability, and create value-added products like powders and dried slices. We all take a closer look at two key drying methods: spray drying and tray drying. Spray drying is a modern and highly efficient method mainly used to produce mango powder. It's ideal for making instant drinks, flavorings, and food additives. This method is fast and yields a fine, free-flowing powders with a longer shelf life.
Spray drying is a drying process used to convert liquid or slurry material into dry powder by rapidly drying it with hot air gas. It is one of the most commonly used methods for producing dry powder from liquid material. This is the spray dryer equipment.
The parts of a spray dryer are inlet air filter and heater unit. Its function is to draw in ambient air, filter it to remove dust or contaminants, and heat it to the desired drying temperature. This will ensure clean, hot air enters the drying chamber for effective moisture removal from the sprayed liquid. Drying chamber. This is the main area where the atomized liquid, like mango pulp, is mixed with hot air. As the fine droplets come in contact with the hot air, they rapidly lose moisture and turn into dried particles. Atomizer or nozzle. It converts the liquid feed into fine droplets by spraying it under pressure. Vacuum pump will create a low pressure environment within the system. This will enhance drying by reducing the boiling point of water, helping in moisture removal at lower temperatures. Cyclone separator will separate the dried powder from the airstream using centrifugal force. Its purpose is to collect the solid particles while allowing the moist air to exit.
Tray drying, on the other hand, is a traditional and economical method used for drying mango slices. This method is cost effective and simple, but it can lead to uneven drying and slight loss of nutrients and color.
This is a tray dryer, and the process of tray drying is done in order to remove water from food materials, and we can also we can improve the texture by removing excess moisture, and we can also prevent spoilage. There are many trays where you can keep the samples. Some samples are kept here. Then there is a drying chamber where the samples are kept, and here you can here that air and heating environment can be controlled. And there are many settings where you can control the temperature and the humidity levels. In this tray drying, in order to use it, we have to prepare the material, and we have to wash them and cut them, and then spread it into the tray and keep it in the drying chamber. And we can control the settings and as per it is required, and then the drying will take place. And the application of it in food is that
we can dry fruits, vegetables, meat and other products, and we'll be able to extend its shelf life.